Right, so now we're actually going to go ahead and fracture this geometry. Let me just drop a normal on this. So you might be aware that since Houdini 17, I think, we've had this node RBD material fracture, which is great. Okay, it does a lot, but I found that for concrete fracturing, you know, to get these kind of wavy patterns, not wavy, but you know, to try and get away from that typical kind of Voronoi look, we're going to push the size of the detail quite a lot, the height. And when I do that using this node, it seems to break quite easily. We get weird holes in the geometry, and you know, it's very difficult to work with. So you know, we will be using this again in other projects, but for this one, I'm going to be using the Boolean fracture, okay, which is also new actually. I think for also in 2017, because it's pretty much just a Boolean, but it sets up your constraint geometry as well. I think that's the only difference. So the workflow. So we're going to first set up some cutter geometry, and then that's going to feed into the Boolean here. Okay, so if we come off to the side here, so we're going to start off with an ISO offset, and let's give ourselves some more divisions. Let's push that up to 50. Okay, so just generating this so that I can scatter some points inside. There we go, and we want to force total count. I'm going to do 100 points, not too many. Okay, and then leave the rest as it is. And what I'm going to do is copy some grids onto this. Drop a copy to point, so the point will go here, and then my grid will go in there. We visualize that, so you can see now the grids are all facing the same way, so that won't really give us a very interesting fracture. So we need to randomize. So grab an attribute randomize. Randomize the easiest way is to randomize the normal, and set that up to 4, and then change this to, let me see what did I use before. I think we can use inside sphere. Okay, and then we get some nice randomized orientation there. Cool, and we also want to, obviously, this grid. So what I don't want is the edge of any of these planes falling inside this geometry, right? So that's going to give us an incomplete cut. So I don't want any, think of these, what we're building here as kind of like blades cutting into this geometry, right? And I don't want any of them to stop halfway through. They all need to go all the way through to the other side of the geometry. So we're going to make these blades really big, and then trim them down to be the same, about the same size as this geometry, right? So this grid, I'm going to make, let's see, sorry, if I visualize it, I'm going to make it 130 by 130. Okay, so maybe if I template that and visualize that, you can see even if the point is here and the center of the grid comes here, then you know it should encompass the geometry completely, right? So that's why I'm making it so big. So give ourselves a nice big grid and lots of subdivision to start. Okay, and then that will be, as I said, rotated around like that. Okay, let me just check the global seed. I'm just going to change this to match what I've used previously. Okay, it doesn't matter. This is just going to randomly change it, but just so that we've got exactly the same results, right? So the same. Let me just check the scatter as well. I think the seed, is just at 0 by default, so that's great. And then we want to add some noise to this. right? So if we drop a mountain here, you can see we'll start to get something. But we definitely, so I'm going to do this in a couple of layers. So I'm going to do big areas of noise and then smaller areas, smaller frequency noise later, or higher frequency, but the scale will be smaller. So I'm going to start with 30 and 30, and normally keep these about the same. Okay, so it's going to give me big kind of undulating size noise, but it's hard to see here. But when what can happen when if I apply this noise to you can kind of see it there. What happens when if I apply this noise to all this different geometry together, it's all working on each geometry in the same way, and it can kind of tend to group and push geometry together, you know, and you can see they're all kind of waving in one direction there. So what I need to do is iterate over each piece of geometry and change this noise a little bit each time. So we need a for each, and we'll do connected piece, and I will just drop this connectivity sub for me and generate this class attribute. Okay, so each geometry here will be given this a different value for this class attribute, and then we iterate over that here, and then we're going to drop the mountain in there. So you can see here, if we come to the last one, so this for each end, it's going to go over each one, and right now it's going to be exactly the same, right? Let's go into single pass, and then we can see each one individually. Basically what I want to do is for each time we go through this, for each block, I want to do something different, and to get a different value for each time we go through, we need this meta import node. And basically all this is it gives us access to this detail attribute. Why don't I see it? Maybe, there we go. Sorry, I think I was on the primitive. So on the detail attribute, we can see we got this iteration and value. So each time we go through this loop, this changes, and we can use that value to give us a per object, you know, a variation. So I'm going to come back here into my mountain. Okay, we need to just use a quick expression here to change. Basically, if I change this time, it's just going to give me a variation. So for each time, each iteration will basically add one, and it will change, you know, substantially there. So we need the detail attribute from the node. So we drop the path for the node, so for each bn1 metadata. Okay, so that's where we need the information from. We want the value and just a 0 there, not doing anything strange. Cool. Okay, so that means for each time we go through, so if I go back to single pass now and watch this, and then go to, I don't know, number 4, come here, we should have 4 there. Okay, so it's not going to look massively different now, but in terms of the fracture, you know, you can do the fracture does take quite a long time, so you know, you can do some tests yourselves just to have a look. Maybe just drop down the scatter so we have less geometry. You will see a difference, right? So I'm going to turn off single pass, and I will go through each piece of geometry there and give me a more, you can see they're kind of not grouping together anymore. They're not kind of all being pushed together into a localized spot. Depends on what you want, really, you know, on the fracture. But I just found I preferred this. So now I want to kind of clip it down a bit. So I'm going to grab a peak sub. So peak will basically just, it's like inflating the geometry based on the normals, right? So I'm going to grab this peak and give it quite a bit more. So push that up to 3, and then group based on that. Okay, so if we do, I think if we do points, that's fine. And again, do delete me. And that, so you can see that's selecting those points. And we need to go to bounding object in this case. Last time was a volume, and then delete with points. Changes to not edges. We need points here. Points. Okay, delete me and delete non-selected. Great, so there you can see it kind of trims it down nice and small. And now when we do that, you can see we've still got, you know, pretty coarse geometry here. So we're going to subdivide this down further. We've only got 92,000 points now and came down from 4 million, right? So let me name these actually. Boundary, let's say. That's fine. So let's, yeah, subdivide it even further. So I'm gonna push this up to three levels of subdivision. Okay, so it's going to give us more geometry to play with. So now we can add some more noise to this, right? So I'm going to add another mountain. I think what I'm going to do is just set this to manual first while I'm setting this up, because we've got, what do we have, 5,500,000 points there now. So just to get this going quickly, okay, so I'm going to do, as I said, a much smaller scale thing now. So I'm just going to drop the height to 0.5. The rest of this, leave it at default. So there's like a medium size one. And then one more with even smaller scale again. So this one will be 0.15 by 0.25 for the element scale. Okay, and then let's set that to auto update so we can see the results. Cool. Okay, so we've got these big waves and then medium sized waves and small waves as well. I think we do have some, I can see some kind of weird floating points there from deleting this group. So if we just drop a clean node, that will get rid of these, because they might cause problems with the Boolean, the cutting of that. There we go. Right, and that's ready to drop into here. Now, if we bring this down, maybe let's just bring this whole thing across, and that will connect this up. So before I do that, maybe I'll save it, okay, or just, well, Control S is fine, because, you know, this is going to take it could take quite a long time, and you know, just in case your computer crashes. So I'm going to drop that in, visualize that, and just wait for that to run through. There we go. So that's done for me. It's fractured up. It took 3-4 minutes. Yeah, depending on your setup, you might want to either, you know, you've got a few options. You can, if you want a lighter, you know, less pieces, you can just lower the scatter number. Okay, how many actual cutters you have in there, or you can lower the subdivide, but obviously that would give you a different kind of quality in the fracture. So we can check this with just a simple exploded view. I'll put that over to the side, visualize that so we get a sense of the pieces, and you can see there with this method we got really nice, lots of tiny detail. We've got some different kind of size chunks, big, everything from big pieces like this to little tiny debris size fractures as well, and it looks really nice. We'll get some really nice detail from this. So really important right away is to cache this, as it takes a while to calculate. So not file, sorry, file cache. Okay. And set this to current frame. In hip is fine, geo, or whatever. If you want to give it to make a new folder, I'm gonna call it fracture dot version 1 dot geo. That's it, and save to disk. And make sure you check load from disk as well.